Hello and welcome back to Introduction to Operating Systems and Virtualization. My name is Scott Neal. Today we are looking at cloud-based solutions. So for today's lecture we will be defining cloud computing as well as discussing a brief history of how cloud computing came to be. And if you're a little confused about some of the terminology surrounding cloud computing, I can at least help you with three of those today as we define software as a service, platform as a service, and infrastructure as a service. We'll also be giving you some examples and benefits of each of those services and even some caveats of using them as well. We'll finish up today's lecture by summarizing why cloud computing is important, as well as giving you a couple examples of how some major hitters are using cloud computing to reduce their bottom line. So what is cloud computing? Well, if I go to Wikipedia as a resource, they define cloud computing as a type of internet-based computing that provides shared computer processing resources and data to computers and other devices on demand. But I really like Mel and Grant's definition from 2009. They define it as a model for enabling convenient on-demand network access to a shared pool of configurable computing resources and services which can, and very importantly, be rapidly provisioned and released with a minimal amount of management effort or service provider interaction. So what does all that mean? Well, by definition, a cloud does consist of many computers. And thanks to the world of virtualization, we now have the ability to spin up and provision multiple types of virtualized resources to our clients as a way of providing a very highly available, highly configurable, and very powerful internet-based resource for our clients and their users to utilize from virtually anywhere in the world. And depending on how much money I want to throw at it, it can be extremely fast. So, how did cloud computing become to be what it is today? Well, if I go all the way back to the 1960s, a fellow named John McCarthy actually came up with the concept of cloud computing, though we didn't call it cloud computing. He really saw that processing power didn't necessarily have to reside with the user or the end user or the company. He actually believed that you could use processing power and distribute processing power very much like we do electricity, water, and any other utility out there. Now, a gentleman named Douglas Parkhill took that a step further in 1966. He wrote a book describing what would become the modern cloud computing architectures of today. However, cloud computing really didn't make any kind of headway until the early 1990s, when we really started using dedicated point-to-point networks and VPN networks as a means to connecting to resources over the internet. Now, the cloud computing, or the term cloud computing, really was coined by a gentleman named Ramnath Shalapa. He introduced this concept of cloud computing in a lecture in 1997. That term cloud computing really has pretty much stuck with us since that day. And if we talk about some heavy hitters when it comes to setting up and using cloud computing, we really can thank Amazon for a lot of this, because in the early 2000s, Amazon really thought about optimizing its network in a different way by utilizing CPU usage, converting its servers from a standardized data center format into what's considered a cloud computing format as a means of reducing the amount of resources needed during peak times and providing and provisioning in a much more efficient way. And it didn't take Amazon long to realize, wow, now that we've done this, we can actually begin selling all this unused processing bandwidth and giving it out to public users. So in 2006, they began developing a model for doing that. Google and IBM beginning to also explore the concept of cloud computing in 2007. They really started looking at funding large-scale cloud computing projects that were carried out by a number of universities. But really, since 2008, we've seen lots of companies begin to get on the cloud computing bandwagon. And now that we are in the 2016, 2017, 2018, we are seeing dozens and dozens and dozens of companies offering many different types of cloud-based solutions to a wide variety of customers. So, What is cloud computing really? Well, if I sit down and think about the architecture of cloud computing, I can really look at 5 different layers of cloud computing. But when we think about cloud computing as a type of service that we can utilize, I can break that down into 3 separate layers. So let's look at these. As far as the first layer goes, the client layer, which is really anything that's going to receive an application, is going to consist of your mobile phone, your internet browser, or even a thin client. The second layer is the application layer. This is where we begin to look at cloud computing from a service perspective. So one of the more common terms that you hear, software as a service, really applies to using this application layer. This is going to include products such as Microsoft Office 365, your Google or Hotmail account, your Google Docs, your OneDrive. These are all examples of applications that are provided as a cloud-based service, software as a service. Great thing about it, it's not an application that really sits on a local machine. I don't need to do an installation. It's just going to run. It's provided to you sitting on the vendor's server. This is generally going to be provided as a subscription-based fee, a monthly fee usually, for running this application. So when the application is running, you're paying a fee for it. The next layer that we think about from an architecture perspective is the platform layer. And coincidentally, it's also considered as a separate service. So, platform as a service is really going to be that layer that's not only the application layer, but it's also going to be responsible for providing the management, deployment, and testing of those applications in addition to the application layer itself. This is referred to as platform as a service. Last but not least, from a service layer perspective, we have infrastructure as a service. And infrastructure of a service really includes the last 2 layers of our cloud computing architecture. That is the infrastructure layer and the server layer. The infrastructure layer is really all that actual cloud computing software that's used to build and run the cloud environment. And that's going to manage everything in the cloud. The server layer is the actual server hardware and the processing power and the storage associated with your cloud computing solution. So, let's backtrack and look at each of these 3 services that we just described, talk about some of the benefits and usage of those services. Software as a service is probably the most commonly utilized cloud-based service out there. And this is great for what I refer to as vanilla offerings, or offerings that do not need to be highly customized. This is software that, if I'm a vendor, I can distribute largely undifferentiated between each of my clients. So if you need Office 365, I can spin up an Office 365 application container. Bam, done. Bam, for the next person, for the next person. Maybe I'll have 1 or 2 things I'll have to tweak, but pretty much the way you use Office 365 for one user is the way the next user is going to use it. This is a great choice when the application is going to promote a lot of interplay, by the way, between the organization and the outside world. So for instance, if I have a sales application that I know that my sales force is going to be using on mobile phones all over the country, and maybe I also want to make that application available to my clients that may want to do web ordering through that application at the same time, well, software as a service may be my solution. Based on how software as a solution is priced, this is also going to be a great choice. Perhaps if I'm looking for a short-term solution, maybe I'm solving a long-term problem. Maybe I'm testing an application that I would like to actually install and run in-house, but it's available as software as a solution. Why go to the expense and licensing costs if I'm not sure I want to purchase that product? So if I have the option to do a short-term subscription, utilize that product and then build it in-house later, excellent opportunity. Most software as a solution products do allow web access to commercial software, and the application will be managed from a central location, namely the vendor. So because of that, that means I don't have to worry about upgrades, I don't have to worry about patches, I don't have to worry about maintenance of the application. This all falls on the shoulders of the vendor. So when is software as a service not a good solution for you? Well, if you're looking for extremely fast or real-time processing needs, software as a solution does not normally provide that unless you're willing to spend a lot of money. And if your organization is already fulfilling a need that in-house, then software as a solution is probably not going to offer any significant advantages to you. So, once again, software as a solution is going to be an application layer involving things like Google Apps, Spiceworks Incident Responses System, which is can be offered as a server-based option, but they've recently also included a cloud-based option. There are dozens and dozens and dozens of types of examples of applications that are available and usable through the cloud. All right, so with that discussed, let's move on to platform as a service. Platform as a service is best described as what we refer to as a collaborative platform. Its value-added services are really what's going to differentiate platform as a service from infrastructure as a service. Usually it's going to include things like the operating system, the programming language, execution environment, all of the databases. All of this is going to be considered the platform for your cloud environment. So this is great for collaborative testing, development. If I've got outside parties that need to have access, they're going to provide input in the developing phase, including injecting proprietary data from their infrastructure. Then platform as a service is an option for you. So things like a web-based interface creation tool is a good example of platform as a service, because I can use it to create, modify, test, and maybe even deploy later on to different user interfaces. However, platform as a service opportunities are not going to be great for you if the application is going to need to be hosted on different locations, or where performance requires customization of the underlying hardware or software. So when we think about platform as a service, if I look at examples, we're thinking about Windows Azure, Amazon Web Service, Elastic Beanstalk, Google App Engine, and of course the Apache Stratos. These are all good examples of platform as a service. Last but not least, infrastructure as a service is going to deliver cloud computing infrastructure. That's going to include, but most often it's going to be included virtually as servers, storage solutions, and network operating systems. So when you talk about infrastructure as a service, this is where you start hearing people talk about public cloud, private cloud, and hybrid cloud. Public cloud infrastructure, of course, is going to be designed to share resources deployed on a self-service basis over the internet. And a lot of times, your first cloud computing opportunity, it will be provided as a private cloud, which is going to emulate cloud computing features including virtualization, and that's going to be on a private network just for your users or your employees. A private cloud may be set up so that they can access these resources without allowing the public to have access to it. Last but not least, there's the hybrid cloud option, where a combination of traditional dedicated hosting is going to sit alongside the public and private cloud infrastructure. And there are a lot of organizations and vendors that are providing a hybrid cloud solution as well as a typical cloud computing solution. We're seeing more and more hybrid cloud beginning to filter into the market. Infrastructure as a service resources are going to be distributed as a service, and they're great for dynamic scaling where multiple users will utilize the same piece of hardware. This allows us to reduce hardware costs, particularly if I have an environment where my demand is going to fluctuate wildly. However, not going to be the best solution if I got high levels of performance that are going to be required and can be met on a dedicated hosted infrastructure. So, what companies use the clouds? Well, Amazon Web Services, Google Mail, Google Apps, Yahoo Mail, Shutterfly, pretty much any kind of web mail that you're connecting through a client browser is really a cloud-based application. Norton's 360 backup service is considered a cloud-based platform. Apple's mobile me service, and so on. So there are dozens of companies that do use cloud technology in today's IT world. Why is cloud computing important? Well, first of all, online applications are becoming ever increasingly popular to run on the clouds. They do provide that high level of availability through the Internet Protocol and through the fact that with virtualization, companies are able to spin up with minimal effort. Once again, part of that definition of cloud computing, the ability to provide these services with a minimal amount of effort. Those two combination of concepts there are really making cloud or driving cloud computing in today's environment. Cloud computing does have the ability to save a lot of money by taking computer hardware guesswork out of the company's infrastructure. Instead of using that money to purchase infrastructure, I can put that money towards productivity. And if you have heard my lectures, particularly my in-class lectures for my students, we all know that IT and IT support really does center around this P word, productivity. That allows us also to take a lot of costs away from the IT infrastructure, things like the cost of maintaining that infrastructure, hiring of people, the support mechanisms in place. That allows us to look at cloud computing from a different light, and that cost savings may make a cloud computing option more viable depending on how we're going to use it. As a benefit of cloud computing, we have near 100% uptime with scalable computational power, another benefit of cloud computing. So, who uses cloud computing? What are some examples of cloud computing? Well, Netflix uses the cloud. They are, of course, an internet subscription service for television shows and movies. And because of the nature of their business, when you think about holidays, you think about time off, when does Netflix see significant usage spikes? Well, of course, these times are going to generate large usage spikes on their network. And if they want to make sure they're providing adequate coverage and adequate utilization for their viewers, they have to have some sort of an infrastructure in place to provide that. But if these fluctuations vary wildly and are not something that are common on a day-to-day level, then that means that that hardware infrastructure that they would purchase would sit largely unused through a significant percentage of the year. So why spend that money on infrastructure? Well, that's a good question. So instead of using or purchasing large infrastructure, which could be very expensive, Netflix decided, as they started to outgrow their data center capabilities, that they would switch to a cloud-based delivery model. So this is going to give Netflix a scalability without needing to increase that large data center footprint. By purchasing and utilizing virtualization as a means of providing this cloud connectivity to their users, they are saving money in the long term because they are not purchasing significant amounts of hardware. They are not having to hire people to support that hardware, and the reduced costs on maintenance costs, power consumption, etc. Xerox also uses the cloud. Xerox, believe it or not, is still around. They do offer a cloud print, internal cloud print solution for their workers to receive any kind of printed content, and it doesn't matter where they are or what kind of printer they're connecting to outside of the organization. This is a complex application, however. Probably far more complex when you think about installing it, managing it, updating it on your own system. Xerox decided the best way to provide this service would be to provide it as a cloud. Because numerous files have to be stored and manipulated and converted into a print-ready format, by utilizing cloud-based technology, they are now able to to provide this service, but eliminate the complications or the user from having to deal with complicated upgrades, maintenance, etc. This is all now hidden from the user. It's maintained by Xerox on their own servers. All the user needs to know how to do is connect to the service, and voila, just about any document that they would want can now be printed on their local printer. So, let's summarize. Cloud does consist of many computers, and cloud computing as we know it is dependent on virtualization to provide vendors with a cost-effective model for providing cloud-based services with high availability. Likewise, cloud computing can be broken down into three areas of service: software as a service, platform as a service, and infrastructure as a service. And processing in the cloud can be performed in many places at once. Once again, thanks to virtualization, being able to do that is very cost effective. Speaking of cost effective, cloud computing does save money. It cuts hardware costs, service costs, and it can do this while providing 100% or near 100% uptime with scalable computational power. If you're looking at cloud computing as a solution for you, remember it's not the greatest solution where you need real-time processing or extremely high performance, or anywhere where your existing infrastructure is going to already provide or satisfactorily meet that need. Last but not least, many companies already use cloud computing. We're seeing more and more companies switch to cloud computing for a wide variety of reasons, and it's not going to be unlikely that if you are working in the IT field, you are going to be exploring cloud computing options as a way of increasing productivity in your environment. Alright, pretty quick lecture today. We are moving to the end of the series. We have one more lesson to go, and I look forward to seeing you then. Have a great day.